Hi everyone, it's Michael again. So today we are going to a walkthrough uh, on how to do Amazon SageMaker and importing data. So in this lab, you will learn how to launch an Amazon SageMaker notebook instance, and from that instance, you will learn how to create a Jupyter notebook. You will learn how to create code and mark down cells within the notebook. You will download data from an external source, then learn how to save your notebook locally so you can continue working on labs across sections. Amazon SageMaker is a fully managed service that provides every developer and data scientist with the ability to build, train, and deploy machine learning models quickly. Amazon SageMaker removes the heavy lifting from each step of the machine learning process to make it easier to develop high quality models. So the objective of this lab, after completing this lab, you will be able to launch an Amazon SageMaker notebook instance, launch a Jupyter notebook, run code in a notebook, download data from an external source, upload and download a Jupyter notebook to your local machine. Okay. So this lab is going to take about 30 minutes. Now, let's go straight to our task one. We are going to create a Jupyter notebook with Amazon SageMaker. In this task, you will access Amazon SageMaker in AWS Management Console and create a Jupyter notebook. To create a Jupyter notebook with Amazon SageMaker, so first on the AWS Management Console, on the service menu, choose Amazon SageMaker. So we're going to choose Amazon SageMaker. To make it easy, I go to the search bar and search SageMaker right here. Click it. After that, from the navigation menu on the left, expand the notebook section and choose notebook instance. On the left side, we go to notebook and choose notebook instances. Now that we are inside the notebook instances, we go to choose create notebook instance. Click that. We have our create notebook instance interface. So in the notebook instance name box, we go to type in my notebook. Okay. So now after we type in my notebook as our notebook instance name, from the notebook instance typed, drop down list and choose ml.m4.xlarge. Instance type ml.m4.xlarge, ml ml.m4.xlarge right here. ml.m4.xlarge is going to be our notebook instance type. Now set the platform identifier to notebook AL2V1. Platform identifier to notebook Now set the platform identifier type to notebook AL2V1 to ensure that you are using the Amazon Linux 2 as operating system type for the notebook instance. To learn more about notebook instance and operation system type options, we can go to this documentation here. So we just chose our instance type notebook instance type ml.m4.x which is correct, ml.m4.x. But we need to set the platform identifier type. This is the platform identifier. Where is the platform identifier type? Yeah, it's right here. Platform identifier, which we already have. Notebook AL2 V1 right here. This is what we need to choose. After that, under the additional configuration, choose a drop-down menu for lifecycle configuration and choose the lifecycle configurations that contain ML pipeline. This automatically adds the correct Jupyter notebook to your Amazon SageMaker notebook instance. So under the additional configuration here, and then choose a drop down menu for lifecycle configuration, and choose a lifecycle configuration that contain ML pipeline. Alright, here. Okay. Now leave the remaining setting at their default values. Then we're going to choose create notebook instance. So leave everything as default. Now we're going to create notebook instance. Awesome. So we have our notebook and it's pending. Okay. So your new notebook is in the notebook instance list with a status of pending. So when the status changes to in service, you can continue to the next step. While you are waiting for the status to change, you can read more about the Jupyter notebook in either of these documentation here. And it usually takes about 2 to 5 minutes for the notebook instance to start. In the meanwhile, while waiting for that, we can click into the documentation and read more about the Jupyter. So Jupyter is the free software open standard and web services for interactive computing across all programming language. So right here says Jupyter Lab is the next generation notebook interface. Jupyter Lab is the latest web-based interactive development environment for notebook code and data. Its flexible interface allows users to configure and arrange workflow in data science, scientific computing, computational journalism, and machine learning. A modular design invites extensions to expand and enrich functionality. Jupyter Notebook, the classic notebook interface. Jupyter Notebook is the original web application for creating and sharing computational documents. It offers simple, streamlined, document-centric experience. We're going to choose a language of choice. Jupyter supports over 40 programming languages, including Python, R, Julia, and Scala. We can share notebooks. So notebook can be shared with others using email, Dropbox, GitHub, and Jupyter Notebook Viewer. Your code can produce rich interactive output, HTML, images, video, latex, and custom meme types. Leverage big data tools such as Apache Spark from Python, R, and Scala. Explore the same data with pandas, Scikit Learn, Glot2, and TensorFlow. Let's check back with our instance still pending. Let me refresh it. Still pending. So we can read more about Jupyter. So Jupyter Hub is a multi-user version of a notebook designed for companies, classrooms, and research labs. They have pluggable authentication, manage user and authentication with Palm, OAuth, or integrate with your own directory service system. They have centralized deployment. Deploy Jupyter Notebook to thousands of users in your organization on centralized infrastructure, on or off site. Container friendly, use Docker and Kubernetes to scale your deployment, isolate user processes, and simplify software installation. Co-meet data. Deploy notebook next to your data to provide unified software management and data access within your organization. Voila, share your result. Voila helps communicate insight by transforming notebooks into secure, standalone web application that you can customize and share. Okay, really cool. So they are open standard for interactive computing. Project Jupyter promote open standard that third-party developers can leverage to build customized application. Think HTML and CSS for interactive computing on the web. Notebook document format. Jupyter Notebook are an open document format based on JSON. They contain a complete record of user sessions and include code, narrative text, equations, and rich output. Interactive computing protocol. The notebook communication with computational kernels using interactive computing protocol, an open network protocol based on JSON data over ZMQ and WebSockets. The kernel. The kernels are processes that run interactive code in a particular programming language and return output to user. Kernels can also respond to tab completion and introspection requests. Awesome. So our notebook instance is in service. Now let's go back to our lab. So at the end of the row, we will choose Open Jupyter Lab to open the Jupyter Notebook instance. Open Jupyter Lab. Okay. Now go to Task 2, Introduction to Jupyter Lab. In this task, you will explore the Jupyter Lab GUI on Amazon SageMaker and work through the sample Jupyter Notebook. Jupyter Notebooks enable you to create and share documents that contain both code and rich text elements, such as equations. So, in the Jupyter Lab GUI, open the folder for your desired language, then open the Python cheat sheet.ipynb notebook file, which was automatically uploaded to the Jupyter Lab IDE. The notebook will open in a new tab in the editor. The Jupyter Lab environment will look like the following image, and you will now examine at its component in detail. Let's see. So first thing first, we're going to open the folder for our design language to open the Python cheat sheet. Okay. Okay, so I'm going to use this folder right here in US English. You say open the folder of your desired language and then open the Python cheat sheet. All right. Let's see. Open it. Mm-hmm. Right here. Now we are going to Python cheat sheet. Okay. Let's go back. So it look like this. So the top include the menu bar, which provide all of the command to control the notebook and environment. It include 5. Use to save, revert, or create a checkpoint for your notebook. Edit is edit your notebook structure, which includes the following commands. Cut, the shortcut is X, copy, shortcut is C, paste, shortcut for paste below V, delete, shortcut is DD, undo, delete, shortcut is Z, view, toggle, different options for your notebook, run commands to run the cells in the notebook, kernel, change the state of kernel or programming language that used by the notebooks. Amazon SageMaker includes various kernels based on Python, depending on frameworks that you want to use. For example, TensorFlow, PyTorch, and MXNet. Git command to interact with Git repository if you have one that's configured to work with Jupyter Lab. Tabs, commands to navigate the notebook labs. Settings, commands to change your Jupyter Lab preferences. Help, information to help you use Jupyter Labs. On the left side of the screen includes the navigation sidebar and the main work area. The navigation sidebar contains the following tabs: 5 browser, list of running kernels and terminals, Git repository viewer, Jupyter Lab command palette, notebook tools. View the open tabs within the environment. View the headings of the notebook. List of SageMaker samples. The main work area in Jupyter Lab enables you to arrange documents such as notebook, text, and others, and other activities such as terminals, code consoles, and others into panels of tabs that can be resized or subdivided. Drag a tab to the center of a tab panel to move the tab to the panel. Subdivide a tab panel by dragging a tab to the left, right, top, or bottom of the pane. The work area has a single current activity. The tab for the current activity is marked with a color top border, blue by default. The main work area has a toolbar which changes depend on the type of file that's open and in focus. The toolbar for a Jupyter notebook looks like the following example. So one is save, insert, cut, copy, and paste. This section right here is run a cell, interrupt the cell, and restart the kernel button. This section right here is a drop-down menu for changing the cell type. The run behavior of a cell is determined by the cell's type. Cells include the following types: code cells, the cells that take input in the form of code; markdown cells, cells that contain additional information as text that's in a language called markdown. The output of the cells is text that formatted similar to HTML page. You will look at these cells in the next task step. Raw NB convert cells, raw cells that don't give you an output. The section right here is the kernel name. and its running status, solid indicates that code is being run. You can run code in the cell on the keyboard by pressing Shift plus Enter, or in the toolbar by choosing the Run button, or in the menu bar by choosing Cells and then choose Run Cells. The first cell in the notebook is a markdown cell. A markdown cell uses Markdown, which is a markup language with plain text formatting syntax. It's often used to format read files, to create rich text and additional documentation in the Jupyter notebook. You will now examine the markdown cell. To look at how to structure a markdown cell, double-click the cell to inspect it. Let's see. Okay, so to look at how to structure a markdown cell, double-click the cell to inspect it. Okay. Yep. That's how we inspect it. Double click this and we inspect this markdown right here. Lastly, you have a code cells that you can use to run your code. A notebook can run code in different languages, but it can only use one kernel at a time. A code cells enables you to write code in a single block with full syntax highlighted. Each cell is run individually, and the order can be found by using the number to the left of the cell in number. Similarly, the output of that cell is given by out number. Run to this notebook one time and then process to the next text. Let me see if I run to this notebook. Code markdown, code markdown. Awesome. So it looks like right here is showing us what Python is, what Panda is, what NumPy is, all the basic of Python. Awesome. So after going through the notebook, let's go to task 3. So open a sample notebook. So in this task, you will browse to a provided sample notebook and familiarize yourself with working in a Jupyter notebook. In your Jupyter lab environment, switch the left navigation view to Amazon SageMaker samples. Switch the lab navigation view to Amazon SageMaker samples. See. In your Jupyter lab environment, switch the left navigation view to Amazon SageMaker samples. close that one out. So switch view. So presentation mode. In your Jupyter lab environment, switch the left navigation view to Amazon SageMaker samples. Left navigation view to Amazon SageMaker sample. Amazon SageMaker sample. Amazon SageMaker. So in your Jupyter lab environment, switch the left navigation view. Switch the left navigation view to Amazon SageMaker sample. Okay. In your Jupyter Lab environment, switch the left navigation view to Amazon SageMaker samples and locate the samples. Name linear learner miss.mb. Choose the sample to load into the main working area. To create a copy, choose copy. In your Jupyter Lab environment, switch the left navigation view to Amazon SageMaker samples. Amazon SageMaker samples. In view, Amazon SageMaker sample. Is it? Where is it? It's in here. Choose a linear learner amnist. Linear learner amnist. In this task, you will browse through the provided sample notebook, familiarize yourself with working in Jupyter Notebook. So in your Jupyter lab environment, switch the left navigation view. Switch the left navigation view to Amazon SageMaker samples. Switch the left navigation view. What does it say? Switch the left navigation view to Amazon SageMaker sample. Look at sample name. Choose a sample to load it into the menu area. To create a copy in the file header, choose create a copy button in the dialog box. Choose create copy again. Choose the lab environment. scroll to the notebook. However, be aware that you won't be able to run the step because the storage book is required. You say in the Jupyter Lab environment, switch the left navigation view to Amazon SageMaker sample. It's right here. Amazon SageMaker samples. Then locate a sample named Linear Learner Mist. Oh, I see. Alright. Okay. It's right here. Oh my god. Okay. So this is the Linear Learner Mist .I P Y and B. So choose the sample to load into the main work area. To create a copy in the file header, choose create copy button in the dialog box. Create copy right here. Create copy, and then choose create copy again. Okay. The sample notebook will be copied to your Jupyter Lab environment. Feel free to scroll through the notebook. However, be aware that you're going to be able to run the steps because an Amazon Simple Storage Service, Amazon S3 bucket is required. Alright, so be choosing Python, select, copy it. Go back. So for task 4, we go to importing data. In this task, you will create a new notebook for your labs and add code to the notebook that will download and extract the data that used throughout the remainder of the guided labs. For this task, you will enter code into the notebook. However, in future tasks, you will work through an existing notebook, so you can save time by not typing. The data you will use throughout the guided lab is a dataset that contains medical data about the vertebral column. To learn more about this dataset, we can check it out here. To obtain, extract, and load the data into the pandas data frame, in your Jupyter Lab environment, choose File and then click New and then choose Notebook. So File, click New, choose Notebook. In the Select Kernel dialog window, choose Conda Python 3 and then choose Select. Conda Python 3. Conda Python 3. And then select. Okay. You should have a blank code cell in the main work area. You will change this blank cell to a markup cell and add some text. On the keyboard, press M. The cell type in the drop-down menu should change to markdown. If not, use the drop-down menu to change the cell type. On the keyboard, press M. M. Okay, let's see. Markdown. Okay. Choose markdown. Next, you will give your notebook a title. Remember that a notebook can contain both code and markdown. Press enter in the cell and enter this following text right here. Okay. To exit the cell and render the markup, press Shift plus Enter. Alright, Shift Enter. Cool. Next, you must download the data from the internet. You will use the URL, but the file is a .zip file. You could download the .zip file and extract it. However, because the file is small, you can download the file to a stream. You will then extract the file so you can save it locally. Start by adding a field import. Alright. So on the keyboard, press enter and then type the following code into the cell. On the keyboard, press enter and then type the following code to the cell. Exit the cell without running the code by pressing exit. Alright. Next, add the code to download and extract the .zip file. So what we're going to do is we're going to add a cell below by pressing B. Alright. And then enter in the cell. Press enter, and in the cell enter the following code. Alright, enter. Paste this code in. Exit the cell without running the code by pressing escape. Okay. Go back. Select the two code cells by holding shift and choosing both cells. Both cells should be highlighted as the in the following example. Okay. So holding shift and choose both cells. Shift. Interesting. Select the two code by holding shift and choosing both cells. Both cells be highlighted. Let's see. Shift and choosing both cells. Okay. Run the code in the two cell by pressing shift and enter. So shift and enter. There's some warning on line 2 right here. If you have errors because of spelling errors, fix them now. In the file viewer in the left navigation pane, you should see the 4 new files. Oh, I see. Okay. Just run. Let's see. Shift enter. Okay. No error. In the file viewer in the left navigation, you should see 4 new files. Navigation. Introduction. Okay, see 4 new 5. 1, 2, 3, 4. Load the files into the main working. Load the files into the main working window by clicking each file. Load the file into the main working window by clicking each file. Examine the file in these. Examine the data in these files. What format is the data in? What does the data? Does the data have column heading? Let's see. First one. Numerical data. This one does have heading. It's a relational column. This one just number. This one relational have column header. This one right here just data number. Alright. You will now load the data from to classes 5. Switch back to your notebook. Select the empty cell. Press enter and enter the following code. So now you will now load the data from the two classes 5. Switch back to your notebook. Select an empty cell. Press enter. Okay, go back. Look this one right here. Okay. This time run cell by pressing shift enter. Shift enter. Okay, so we have data running. Awesome. And task 5. Task 5 is downloading your notebook and saving your work. Optional. So when you are finished with the lab environment, or if the time allocated to the lab environment expire, your SageMaker instance will be terminated. You will lose any notebook you created. If the lab requires you to save your notebook, the instructions will clearly indicate that you must do so. If you want to save your notebook yourself, you can use the instructions. So in the file browser, in the left navigation, right click the file that you want to save, then choose download. So let's say I want to save this file right here. Right click and download it, and it's going to download that file. Cool. Next, choose the location where you want to save your file in the local computer. If you want to continue working in the notebooks, start the lab environment again, create a notebook instance, and upload your notebook that you downloaded. Awesome. So that is it for the lab today. So in conclusions, you have successfully launched an Amazon SageMaker notebook instance, launched a Jupyter notebook, ran code in a notebook, downloaded and extracted data from an external source. Thank you so much for watching, and have a good day.